All right, so I'm going to be covering data set Tidy Tuesday of Bob Ross paintings. First things first, let's set up this index.qmd with some chunks of code here. This first chunk will just be reading in the code. Already did this in my pseudocode here. You can see these first two chunks I have. Um, we'll just copy these in. So, and then we'll go over what each thing does. Okay, so I'll read this first one in. This warning message equals false is just when we compile the QMD, it doesn't show any warnings or any unwanted text with loading in this package tidyverse. Same thing here with this warning and message. Down here, we're just reading in the data. Um, I'm naming it Bob Ross. And I'm saying read underscore CSV. You can get this link from the website of Tidy Tuesday where I actually got the data set. So let's go to our environment. We can see when we read that in, it goes into our data. So we can click on that and then we can just kind of inspect and see what we're looking at with our data set. So we can see all the columns up here, painting index, image, painting title, season, episode, num colors. Pretty sure that's just the number of colors used. Got a YouTube link, all the colors used, those colored codes. And then here are all the possible colors that Bob Ross uses or has used in the past. And they're all listed and true if they were used, false if not. And then you can even do a little glimpse. And that just shows you as well. It's a little, I don't know if that's actually needed because you can just kind of open it. But if you have like I know Python's kind of weird when you try to look at data sets like that in your environment. Um, so if you are on Python, I'm sure there's a package like that that you can use to kind of just look over the data. Okay, so the first thing we got right now is every color is in its own column, and what we call that is wide format. And then for counting and plotting those colors, it's much easier to have one row per painting, like per painting color. So we're going to use pivot longer to do so. And so while we use pivot longer, we're then going to filter out to only keep rows where the color was actually true or used. So the value will be true. So I'm going to make color underscore columns. And then I'm going to use names and then our Bob Ross data set. I'm going to do 10 because that's when the colors actually start. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's where you can see this column number 10 is when these colors actually start in the data set. So that's what we want. So 10 colon, I think it's a colon, n column. So that's just saying we want to start at column number 10 and then go to the very end of how many columns are in our data set because we don't have I mean, 10 through the rest of our columns are just all colors. So we don't actually have to go in and count the number of columns. We can just do n column and it'll go to the very end and of that Bob Ross data set. Second, we're going to use pivot longer. So we'll just create color long equals Bob Ross. And we will do a function pivot longer. This is in that tidyverse package that we loaded earlier. And while we're doing this, we're going to name our new columns. Actually, first we're going to tell it what columns we want. So all underscore of those colored columns that we just read in and that we just told or color columns that we want to work with. And then we're going to change the names to, and then make sure you put what you want the names to be in quotation marks, or else R is going to read it as some sort of function, and that just can cause errors. So color underscore names we can use, or do I want to do, yeah, we can just do color underscore name. Oh, and then you also need, let's not forget to add that. And then the values underscore 2 equals used. So we want all the used colors. And we'll end that function. And then, so what we need now, because we have the color columns and we're pivoting it longer to color name and then values to used, but we actually haven't told R yet what the used is. So now we need to create another, just a small little function that tells R colors underscore used equals color underscore long. I don't want colors there. I'm just renaming that function. Oh, sorry. And then just like this, yeah, just like last time. And then right now we're just gonna do filter used. Couldn't I find function name? And that's an error because it's actually the function names. Make sure we're not messing that up. Attempt to apply non-function. Okay. Read that in. Attempt to apply non-function. Hmm. Okay, guys, so do we see this parentheses, these ending parentheses in this column? This, where we're telling what columns to get it from? You actually need brackets here. So when you're doing end column or end row, where you're saying what rows you want, you need brackets instead of parentheses. And then the data set's fine, just having parentheses. Okay. Arguments in. That. Problematic. Name 2 equals color underscore name. Did you misspell an argument name? Yes, I did. It is names 2, not name 2. And there we go. Okay, so let's do our colors long. And look at this. So we combine all those colors from black all the way down to alizarin, crimson, into just one big long column of the color name per painting. So how many colors are there? So I think that's the last color right here. This one. And then use is this true or false. So instead of just having many columns and just true or false values, we just have one column for the color for each painting. It just names out each color and then true or false if it was used or not. Let's go to our color used. And then it just kept all the trues. So because it's actually not like a um what am I thinking of? Like an integer value, we can just say filter used. So if it's true, it'll keep it. If not, it'll just get rid of it if it's false. Okay. Now that our data is finally in long and counting colors is just one line, we can now we can count by color name. Um, Probably easiest to sort by descending and then slice the top 10 and bottom 10. So we're gonna get the top 10 and bottom 10 most used colors. Um, Then we can visualize this with a bar chart. Bar chart's probably the best way to go here because it's going to be easier to see color names that are long, not a vertical bar chart or a horizontal one. Those long names are going to be harder to see on a vertical bar chart than a horizontal one, so we can stretch those names out a little more. We're going to use a little thing called chord underscore flip, which is going to flip the coordinates around for us. That's in ggplot. Um, so let's do color underscore counts equals colors underscore used. And this is just going to be another pretty simple function. We're going to count color underscore name sort equals true. So we're going to sort that. Color counts. So here's all of our counts. That's interesting, isn't it? Titanium white and crimson color. That's going to be tough to work with. I don't really like pronouncing that. Indian red used one time. So yeah, as we can see, there's a pretty big gap between some of these colors. I mean, he's got his ninth most used at 306, and then all the way down to 14, which takes a big dip. That's pretty interesting. Let's just make another variable. There's data set, data frame of our most used colors and our least used. So these are going to be the same code, um, except we're just going to change the names from most underscore used to least underscore used. And we're going to use different functions here. So color underscore counts, we're going to use that we just created. And we're going to go slice underscore head. So we want the top ones, and then n equals 10. That's telling R that we want the top 10 ones. Now we can just copy this. And let's just change this to least use. And then instead of slice head, we're going to do slice tail. And that's just telling R we want the last 10, least most used. So as you can see, sap green at the 9 spot. And then that's funny actually, because there's only 18. So we're gonna have some overlap here, which is fine. That's fine. But maybe we would come back and change that if it's a problem later on with only two overlapping. It shouldn't be. Sorry, let's scrap that. Yeah, we can just scrap that in here. Okay, we're gonna use our little friend ggplot. This is probably the most common plotting method used in R. We're just gonna use the most used data that we got. So that's where we're going into our data. Let's just saying the axis. We're gonna name x-axis equal to what's that? Most used axis x. We're actually gonna reorder this. Let's reorder color underscore name and then we're gonna do the same, just and close that parentheses. Geom underscore color call, but that stands for color. So fill equal to, you can make this in, I mean, you can just type in a color. There's some pretty cool ones out there. Let's just go with blue. And then, I mean, if it is a color, it's usually going to fill in with that color, as you can see. And then chord underscore flip. So it's going to flip those coordinates that we talked about earlier. It just makes those names seem a little easier to read. And then we'll use the labs to title this. Title equals most common used Bob Ross colors. This is pretty fitting. That's and that parentheses quotation mark. Sorry. Let's do X equal to color. Y equal to number of paintings. Capitalize that. Okay. And here we go. Here's our top 10 Bob Ross colors, horizontal bar chart. And we're going to do something very similar. So, I mean, as you can see, there's not a whole lot of difference. Yeah, titanium white, this crimson, and this brown. All three used over 300 times. I think this titanium white is actually just 400. 400 exactly. That's pretty cool. So, yeah, just a cool way to kind of look at how colors are being used. And then, I mean, we can do the same exact thing, just change up a little bit of the code for the least number of colors used. Paste that in here. Okay. So we're gonna go, instead of most used, we're gonna use least used. Again, reordering. This is just sorting the bars by count. So we don't want like we want a visually appealing plot, right? We don't want titanium white to be like in the middle here, and then it's just all out of whack. And you're seeing bars not just follow this pattern, like decreasing pattern, or you can even do an increasing pattern. So yeah, we just want a plot that kind of just flows, right? And then reorder color name, keep Yeah, let's change this title. The least common use Bob Ross colors. Axial color, we're gonna do this chord flip again. And then number of paintings, let's just change this to fill. Let's do green. I wonder if we can actually try ban_Dyke Brown. I don't think it's a color worth a shot, and it's not. That would have been cool though. We'll just do green of that, and that is a pretty nasty looking plot. Let's change that color. Um, do orange. Perfect. And this plot's a little more interesting than this most used. This most used doesn't have a lot of differences between colors. I mean, I mean, over 100 and some, but compared to this, I mean, because we saw Indian red have one time being used, it's just is a little more interesting to look at how once he really doesn't like it, doesn't use a color, it goes down in a hurry. Okay, so let's head to the next step. We are going to do, for this step, we're going to use our original data, this wide data. We don't need the long format. We're going to group by season here. So we're going to do average color per season. We're going to visualize this with a line plot, just because I think there's 8 seasons, maybe more. Let's see. I need probably just do max season. Oh, there's 31. Yeah, not even close to 8. Yeah, so a line plot's definitely probably the best point. Um, so we can just see the 31 seasons span out, and on the y-axis, we're gonna have the number of colors used in that season. Okay, so let's make a season summary here. Let's spell things correctly. Jeez. Season summary equals, we're gonna take our original Bob Ross data, and then we're gonna group by season. And then we're gonna summarize. So it's summarized with a Z. And we're gonna summarize by the average number of colors and equal the mean of colors. Num colors in our Bob Ross data. So as we can see, this is num colors per episode. And good paintings in season equals N. So it's just gonna fill in that mean. This season summary, and there we go. It gives us all these seasons. I'm down to 31. Paintings in season, each has 13 episodes. And that function just gave us an average number of colors. Next, let's plot this. Back to ggplot. We're going to use season summary that we just made. Axis x equals season. Y equals av colors. Then we're gonna do geom line because we don't have a line graph. Color equals, we want something probably dark green. That should work. Mhm. Geom underscore point. This is the size of the lines here. The size, we'll do size equals 2. Color, let's do dark green again. Parentheses, dark green. And then we'll label it. Title equals average number of unique colors by season. X will equal season. Y will equal average colors. The X, see, I missed the X equals here. Sorry. Gotta tell what we're using. And here is our line plot. So that is really weird. Does it start at 0? No. So it starts at 7 and then goes up to 12. So it goes from min to max. So there isn't, I mean, there is kind of a trend. First season he hardly used any, but then he kind of chops back and forth up in this mid nines to 11 and a half range from the rest of the seasons. It's pretty interesting to see. Hmm. Okay. Wonder what happened here. What is the fifth season here? I went down and then he kind of got back on track. It's pretty interesting. Okay. Next, let's write a reusable function. So just get another R chunk here. Oh, so we've been using that group by quite a bit. Um, as up as like we're making these new data frames. This group by, we've been using that quite a bit. Let's summarize this so we can use it every time. We want to count colors. Let's wrap it into a function. A function is going to have these curly brackets. Um, so to do this, we're going to pass a column name as a variable. Tidyverse is going to use this. And then once we use this function, it's going to count the colors by season. This function is going to count how often a color appears. So let's name this function count color use. And then we're telling R we want a function data. So these are going to be the components of our function. And then group variable. And here's our curly brackets. Let's go data group by. So all we're doing is wrapping something like this into a function so we can use it pretty quickly instead of having to write all that out. Curly group underscore variable and those curly brackets color underscore name. That's what's going to be passed through the function. Summarize. Yep, 2 of them times used equals, and so it's going to, R is going to count that. The function is going to count this for us, and will just be the output. Then dot groups equals drop. So we don't want groups in here. Curly bracket. That function should be good to go. Yep, okay. So no problems there. Let's check this out now. So we'll do color. We'll create a new data frame, color by season equals colors used. So we already have colors used. This was the pivot longer we used in the beginning, or we created in the beginning. So that's what we're going to use. So it's going to be our data frame that we're going to use to create a new one. And then we're going to use our function here, the count underscore color underscore use season. So it's going to take season in. And we should get the same as the season summary. So let's get rid of this. Let's run this in. Color by season. So it's not, this is not the average, sorry guys. It's a completely different thing. So yeah, this just says times used in the season. So that function passed in the color name, times used, so it went through, counted all these true and falses for each season. So we should see 1, 2, 3, and 3 for this black. 2. Oh, 1, 2. This is just season 2 already down there. It is season 2. Okay, yeah. So it goes through each season, just goes those color columns and counts if they're true or false. And if it's true, adds one. So this crimson, I mean, it's still just showing up all over the place. 11, 12, 13. That is his fan favorite. So yeah, that function helps us just kind of just type in that what we want to see, instead of having to go up here and use this group by. The next thing we're going to cover here is joining tables. So once again, let's just set up another R chunk. Um, so season summary has one row per season. Average number of colors, and then paintings in season. That's all the season has, down to 31 seasons. But Bob Ross has one row per painting. A left underscore join on season will attach the season average to every painting. Then mutate lets us flag which paintings use more colors than their season average. So we're going to join tables here, and then we're going to investigate which paintings use more colors than their overall season average. So let's create paintings underscore width underscore average equals, we're just going to use the Bob Ross data set, the original one. Left underscore join season summary by equals season. That's what we're going by. Above underscore season underscore average equals num underscore colors greater than the average num colors. Let's end that. Oops, I'm missing a We didn't use a mutate. Here we go. Mutate. Let's close that off. So this goes with that. Yeah. Paintings with average. Here we go. Let's inspect this. So it just went, this it tracked the average number of colors each season. So here's all of season one, paintings in season 13. That's going to be the same for all. And then it goes by each color. So above season average is true for this, his very first one. So number of colors was 8, season average was 7, and then he was above average of the season. So let's find a false one. False. Average 7. He used 3 colors. I'm gonna have to look into that painting. That's impressive. 3 colors. Yeah, I mean, it's just another, we can join the tables with that right there. You can just add the average number of colors and then paintings in the season. That's not really necessary because all of the seasons have 13. But I think it's a pretty nice thing to add. See the average and see if it's just above the average. You might not even have to have the average number of colors either, just because it's the same for each season. I don't know if you want to continue to look at that, but this average above season average is pretty neat to look at. Okay, let's look at the color trends across each season. Let's do the top 5 colors, a total count. So let's do top colors equals color or sort counts. We'll slice head, so slice top. And equals 5 on the top 5. And then poll, so what we want is the color name. Top colors, titanium white, we can even do. Or we can just look too. Uh, most used. No, not colors used. Color counts, yep. So titanium to yellow. Let's get rid of some of these. Okay, and then we'll do top by season equals color by season. Filter on the color name and then in with percentage signs in top colors. So we're telling it to use the top colors that we used. So right here, tops. No, that's not right. Top colors. There we go. Top by season. There we go. It's always it's gonna be that pretty often. Season 1, season 1, season 1, season 1. Okay, let's just graph this real fast. Pretty simple. ggplot, use top by season. Axis X equals season, Y equals times used, color equals color name, and then let's just do geom line. Then we'll do geom point. You don't even need that geom point. Or I think you do actually, geom point. And then labs title equals top five colors by season. Let's add quotes. X equals season. Y equals times used. Color equals color. There we go. That's not a very appealing graph. Um, yeah, I don't know what that doesn't do too much for me, honestly, because his most used colors are not very spread out. I mean, there's some down here, which is only six. This Van Dyke Brown, but yeah, these things are pretty common. These up here, I mean, you can see some chop, but he doesn't really stray away from those top colors. All right, and to our last and final. Um, I'm going to do episode order and the correlation. Let's do a single running episode number across all seasons using row underscore number after sorting. Then we're going to use a scatter plot with a trend line to see whether Bob Ross used more or fewer colors as the show went on. Um, and let's find the correlation coefficient with that. So let's do Bob underscore Ross underscore ordered equals original data arrange season episode mutate episode underscore ID equals row number blank. R will fill that in when going through it. So let's read that in. Bob Ross ordered. That was not necessary. Oh, episode ID here. Yeah, there we go. I mean, still nonetheless, I don't really think you needed to do that. Oh, yes, you did need to do that. You did episode ID. Yes. Okay. So now we have an episode ID for each episode. So let's do ggplot, Bob, Ross, ordered. Axis, do X equals episode ID, Y equals num colors. We'll do a geom point again. Let's do alpha. This is our line here. Was 0.06. No, not 0.06, 0.6. Um, color equals purple. I don't think it likes a capital P. There we go. Um, geom smooth. So it's not going to be any grid lines. Method equals LM. C equals false. color equals that. And let's label it labs title equals colors used across episode order. X equals episode order. And Y equals unique colors. There we go. Doesn't seem to have a correlation, does it? I mean, it's pretty much zero. I mean, yeah, there's a little bit with this. You can see a line, but huh, yeah, not much. That kind of confusing because season one, it was a whole bunch. Let's just find the correlation here. So, do Bob Ross ordered, and we want episode ID. Now Bob Ross ordered with num colors. Okay, so it's not 0, 0.17. Not too far off. As you can see, yeah, there wasn't really a big correlation between going on throughout the episodes and number of colors used. So yeah, let's just save this and go through each thing again. So yeah, if there's any questions, feel free to reach out. I hope you guys enjoyed my screencast and learned a little bit about Bob Ross today. Thank you.